Hi, welcome to our first video on 3.3 rational exponents. Our success criteria: I can simplify and or evaluate expressions with rational exponents. Rational exponents just mean fraction exponents. So that is something new for us, so we'll learn how to handle those. To get started, you can get out your calculator or Desmos. We're going to do a couple comparisons here. It's going to clear some of this off. So it says compare 4 to the exponent 1/2 with the square root of 4. So be careful typing 4 to the exponent 1/2 in your calculator. You may need to use brackets. So like this, making sure that your whole exponent, your whole fraction is the exponent. Okay, you could also write it in as a decimal, 4 to the exponent 0.5. That also works. So compare that with the square root of 4. Well, we know the square root of 4 is 2, so that obviously means these are equivalent. 4 to the exponent 1/2 is equal to the square root of 4. This may be coincidence. Let's try with some other numbers. So 9 to the exponent 1/2. Let's compare that with the square root of 9, which is 3. So they're the same. So I see that 9 to the exponent 1/2 is the same as root 9. So what this is implying is that when an exponent is a half, it's actually equivalent to doing a square root. Let's see if we can see this algebraically. So it says consider the equation 3 squared equals 9. Okay, this is a true equation, 3 squared equal to 9. And we want to raise both sides of the equation to the power of 1/2. So that means just take the left side, raise it to the exponent 1/2, and then do the same thing with the right side. Okay, we can apply the power rule. That's because we have a power raised to an exponent. So that means we have to multiply those two together. So this will just work out to 2 times 1/2 is just 1. So the left side is just 3, basically. And it equals 9 to the exponent 1/2. Well, I can rewrite 3 as root 9. So there we go. We kind of have it algebraically. The square root of 9 is actually equivalent to 9 raised to the exponent 1/2. So that kind of just shows us that this exponent 1/2 means a root symbol. So I do have a great video showing on how x raised to the power of 1/2 means the square root. So be sure to check that out as well. So we can conclude that this x raised to the exponent 1/2 is actually equivalent to just doing the square root of x. So you can go ahead and pick anything you want for x, and you can do that in your calculator, and you can double check. There are some exceptions though, or restrictions for this. So remember, taking a square root, x always needs to be greater than 0. All right, so in fact, we can actually take this rule a little bit further, and I'll show you how this works out too. But x raised to the exponent 1 over n, well, that actually means when we take the root of x, this number on the bottom here in the fraction, that actually tells me the index of the root. So just like you can take the square root of a number, a square root has 2 as a denominator. Well, you can also take a cubed root, and it would have 3 in the denominator, or a fourth root. So a few things here that we can write out. We can say that n is actually referred to as the index of the root. So an example here, if we had x to the 1 over 4, this just means the fourth root. And we could write it as 4 and then the x. So it's a little tiny 4 that goes in here, and we call it the index. And remember, just since we're talking about radicals, this part inside was called the radicand, and the whole thing is called the radical. Okay? Let's maybe write that down so that we can remember that. So we can say x is the radicand, okay, and the whole thing is called the radical. All right, so pretty soon we'll talk about how to evaluate powers when we have a fraction exponent. So how can we actually calculate the value? That's what we're going to do in this next example. So it says powers with rational exponents in this form, 1 over n. So we can see we have 8 raised to the exponent 1 over 3. So let's begin with that one. 8 raised to the exponent 1 over 3. What does this mean? Well, this is actually equivalent to the cubed root of 8. What this means is there's some number that if I cube it, I get 8. So there's some number that exists that if I cube it, it gives me 8. So what would that number need to be? Something cubed equals 8. So something times itself 3 times gives me 8. And you might say, well, I'm going to say that's actually pretty easy. 2 cubed equals 8. So that's actually going to be my answer for the cubed root of 8. So it kind of like reverses doing a cube. So 2 cubed is 8. Well, the cubed root of 8 is 2. It's actually like doing the inverse. Okay. So we can say, therefore, 8 to the exponent 1 over 3 is 2. So you don't need to write all this stuff out every time. I'm just kind of trying to explain it a little bit here. So whenever I see an exponent 1 over 3, I think, what number cubed gives me this base? That's kind of how my mind goes to doing those. All right, let's do a couple more. And then I'll get you guys to practice a few. So we have negative 32 to the exponent 1 over 5. So that means what number raised to the exponent 5 equals negative 32? Think of like doing the reverse, okay? So when I see the fifth root, some number times itself 5 times gives me negative 32. All right, so if you want to pause the video and try to figure that out, you can. And our answer is going to be just negative 2. Has to be negative because the base is negative here. So negative 2 times itself 5 times equals negative 32. Okay, let's try the next one. So we're gonna have to compress this because we're gonna run out of space. So we have negative, and then we have 16 to the 1 over 4. So be real careful. There's no bracket here like there is on this one. So this negative is on the outside. So what that means is basically evaluate this part first and then make it negative at the end. So 16 to the exponent 1 over 4. What that means is, I'm just going to change colors. It means something to the exponent 4 equals 16. Okay? So I know that something needs to be 2, because 2 times 2 times 2 times 2 is 16. So my answer, maybe I'll leave it in pink, it's going to be negative 2. If you want, we can do a check real quick on our calculator. All right, so we have negative 16 to the exponent 1 over 4. Negative 2. Okay. Notice that the brackets do play a big role in this. Okay, if there were brackets around that, yeah, that would be undefined. It would have to be an odd base. So, yeah, we can close that off. But we'll go ahead and we'll keep kind of answering these and checking them. All right, so part D, right here, this one. We have 16 over 81 to the exponent 1 over 4. So this means that, let's write it out here, for 16 over 81 to the 1 over 4. Remember, if I were to write this as a root, I'd have to root everything, the top and the bottom. But it's not the square root. Remember, this is my index. It's the fourth root. So some number times itself 4 times equals 16 over 81. So you can even think of it like this. You could split it up over 2. You could do the fourth root of the top divided by the fourth root of the bottom. Okay, so what number times itself 4 times gives you 16? So, well, that's going to just be 2. We did that in the last question. What number times itself 4 times gives you 81? Well, 2 times itself 4 times is 16. You could then try 3. 3 times 3 is 9. And then times another 3 is 27. Times another 3, 81. So that's just going to be 3 there. Okay. All right, so that's that answer. And we got one more to do. We have negative 27 inside the bracket to the negative 1 over 3. So now we got a negative exponent. So what do you think we need to do? So if you remember from last section, when you have a negative exponent, that we can rewrite this as a positive exponent if we move it to the denominator. So 1 over negative 27 to the 1 over 3. Okay, don't flip this or anything. Remember, you just change the sign and you bring it in the denominator. All right, and now we can just focus on the bottom part. So negative 27 and 1 over 3. So that means the cubed root of negative 27. Well, what number multiplied itself 3 times gives you negative 27? So I'm just going to write this out real quick. That's it in the radical form. So what number times itself 3 times gives you negative 27? Well, that's just negative 3. Okay, so my answer, I can just write negative 1 over 3. And that's solved. Okay, why don't we take a break? We're going to stop this video. And when you come back in the next one, we'll just do some more examples. I'll see you soon.